All right, let's get started. So I want to remind you that, well, first of all, PS 10 is due today, or tomorrow if you use a late day. And on Wednesday, PS 11A is due. Not many of you have done that yet. All you have to do is let us know, what your group is for PS 11. It's either you, yourself, or you and a partner. So be sure and take care of that. It's worth 5 points.
What about people on camera?
People on camera?
Can they pair?
Yeah, anyone can pair, no matter if you're sitting at home or here. But you need to find a partner. Now, how many of you still need a partner? Just saw maybe one hand. But anyway, at the break, why don't you, if you need a partner, why don't you come up here and we'll see if we can fix people up. Any questions or problems about anything? Yeah?
It seems like there's no participation assignment in the book for this Wednesday and next.
Okay, so he's asking about the book. So there's one book assignment this week, next week, and the week after. I don't think any of them are challenge activities. They're just participation activity on one of the days each week. Okay, any other questions? Something I was going to say and now I forgot, but hopefully it'll come to me later. Yes, 11. Okay. One thing to know is that after Thanksgiving, we will, PS 11D, I think it is due, and probably C. And that you got to meet with a TA with your group, either you or you and your partner, if you have a partner, for 10 minutes to demo show progress. And so I'll have the appointment slots should be up soon, and you can start making appointments. That needs to be done next week. I'd really appreciate it if some of you would do it early in the week so that we don't get crushed at the end of the week. So if it's possible for you to make some progress to demonstrate, please do. And remember what I was going to say, Wednesday we will have class. Of course it'll be videoed as usual if you can't be here because of Thanksgiving travel. Also, we're going to cancel all TA hours appointments on Wednesday because there's really nothing new that you need a TA for, and I figure they'll be sitting there idle all day anyway. So, need to see a TA do it today or tomorrow. Okay, I'm going to return to what we were doing last time, and just to remind you, we've gotten to step 4 of my paint program. And this is the state it was in. So our paint program comes up, we can pick rectangle, green, let's say, and draw one. You can say, give me a red line and place it, or an oval and place it. What we haven't been able to do yet is, when we place it, actually size it. We'll worry about that later. And that's what it'll do. In terms of what's on the inside, if we look at our paint panel class, we've just gotten to the point where we declared an interface called shape. And we say anything that claims to be a shape had better have a paint method. And then we declared our oval class to implement shape, our rectangle class to implement shape, and our line class to implement shape. So we had to add that to the program, but what do we get in return? What was the benefit of having these 3 classes that represent the things we can draw on the screen? Implement the shape interface. Yes?
The shapes are properly layered, so the ones you draw after the later you draw them, the more they're...
Okay. So I'll paraphrase what he said. When we paint the paint panel, when the paint panel has to paint itself, when Swing decides it's time to refresh the display, we have to iterate over all the shapes and paint them. And before we had a shape interface, this was a little more complicated. What did we have here before we had a shape interface? To simplify life. Yeah?
You had to paint all the circles and then paint all the rectangles and paint all the lines separately.
Okay. We had 3 loops. We had 3 instance variables. One was a list of ovals, one was a list of rectangles, one was a list of lines, and we had to iterate and draw all the ovals, and then we would draw all the rectangles, and we draw all the lines. And if we were to add another kind of shape to the program, we'd have to add another loop. And not only that complicated the code, but as he said, things weren't being, the last thing you draw you'd expect to be on top. But if the last thing you drew was an oval, it would be on top of all the rectangles and lines. So this is a little cleaner. And the other thing that simplified life is, before we had 3 instance variables right there. We had, like I said, 3 lists for each kind of shape. Now we just need 1, and we can put rectangles, ovals, lines directly into the list, which happens right here when the mouse is pressed. So here no matter whether we're creating an oval, or a rectangle, or a line, we just add it to the list. Just need the 1 list. So that's where we stood last time. Any questions about this before we start modifying it again? Okay, now someone asked a question which was, instead of using a shape interface, what if we just call this array list a list of objects? Because everything is an object. So I want to explore that. So I'm going to go to, I thought it was 4A, but I don't see it here. So I'm going to copy this. And I'm going to paste it back as Paint 4A. Okay. So right now it's identical to Paint 4. But we're going to make a simple change. I'm going to make this be just an array list of objects. Because we know every class is a subtype of the object class. And then just for good measure, since I don't need the shape, I'm going to get rid. I'm not going to say class that oval implements shape. I'm not going to say that rectangle implements shape. I'm not going to say that line implements shape. I'm just going to go with objects. And then I'm going to even get rid of the interface shape. All gone. Now this is going to cause some problems. Why are there errors in the program now? Yeah? Let me get him back. Yeah.
Because you have a form that iterates over shapes.
Okay, I've got rid of the name shape, and so anywhere that I use that type, we're in trouble. So let's just look at the problems and fix. So right here I'm saying shapes is a new array list of shapes, so of course we've got to change that to object because that's what we have now. Yeah, it fixes that. And let's look for, if it doesn't complicate our program, if we're just fixing small bits here and there, maybe using the interface was a waste. Let's go to the next error. It says paint all the shapes. We just need to make this object, because there is no shape interface anymore. So that's fine. Now we can iterate over all the objects in that array list, which you call shapes. We got a problem though here. What's that problem? We're only painting rectangles, ovals, and lines. So why won't Java let us call the paint method on S right there? Yeah?
Java doesn't know that you necessarily only call ovals, rectangles, and lines, so as far as Java is concerned, you might be asking it to paint the string.
Right. So what he's saying is Java's just going by this type. It says, okay, S is an object. Objects don't have a paint method. So the error says the method paint is undefined for the type object. That's reasonable because we could store a string into that array or an integer or anything, and it's not guaranteed to have a paint method. So that's a problem we're going to have to fix. We'll come back to that. Okay, right here, it's just a matter of changing that again to object. So that's fine. We create an oval, it's an object, we can store it in an array list of objects. So far, we just changed shape to object everywhere, except for this one mistake. Now, we have more information than Java. We know that S is going to be a rectangle, an oval, or a line, because we wrote the code that puts it in the list. So here's how we can fix it. If we know, if we happen to know that let's say we happen to know that everything in the list is an oval. Let's just pretend that we're only ever going to create ovals. What we can do is do something like this. And that fixes our problem. So that right there is called that's a cast, or more specifically a downcast. We're casting from a superclass to a subclass. We're casting from object to oval. And that doesn't change anything about the object itself. It doesn't modify it. It doesn't transform it. It just says, okay, from now on we're going to treat S as an oval. So we just basically telling Java, it's okay, I know S has to be an oval, so let's treat it like an oval. And once you cast it, then you can call the paint method on it. So let's see how this works. So let's put a red oval on there. That's good. Let's put a green oval. Let's put a blue oval. That works. But what won't work? Right. Let's put a blue rectangle. And we get an error message, an unhandled exception. And it is a class cast exception. It says rectangle cannot be cast to oval. So if we go back to the code, the way I described it was, we know better than Java. We know that this S has to be an oval, so it's safe to do that cast. But it's not if it happens to be a rectangle. So what can we do about that? Sometimes it's not an oval. Yeah? Okay. Yeah?
Try running the program, casting to an oval, rectangle, and line, only to an error if none of them work.
Okay, so basically we could put a try block around this, and if the class cast exception is thrown, then we could catch it and try to cast it to a rectangle, and if that throws an exception, then we'd catch it and cast it to a line, and that shouldn't throw an exception given the way we've written our program. Fortunately, there's a cleaner way to do that than nesting a bunch of exceptions. Yeah?
Instead of making it an oval, you just make it a shape.
Well, he said instead of casting it to oval, could we cast it to shape? We could if I hadn't gotten rid of shape. And also, the experiment is to see if we can do without shape, if we can just make do with object. So let me show you how to do that. There's a way to test if a cast will be successful. So you can do this. You can say if S instance of oval okay, so what that says is if S is an instance of oval, so if the object stored in S, the object that's referred to by S, is an oval, then we know it's safe to do the cast. So this is how if this test passes, you're guaranteed that the cast will succeed. And then we just gotta do something similar for rectangle. So we'll call that R for variety. Spell rectangle correctly. And we would need the same thing for line, which I'm tired of typing, so I won't do it. But once we've done that, we're good. Now we can put ovals down. We can put rectangles down. And if we try to put a line down, what will happen? No, it won't throw an error. Because we never try to cast it. It just won't. Nothing will show up. It's not, lines aren't being painted because we don't have any code in here that deals with lines. Yeah?
So, I'm sorry if I just didn't catch it, but why do we need it? Why do we need that instance of? Like, what's the importance of that?
Okay, he's asking why do we need the instance of? We want to know whether this cast will succeed. We want to know whether this S is an oval, or whether it's actually a rectangle, or whether it's actually a line. We ought to have another block. So we're testing it to see if it can be cast to oval. If it can, then we do it and paint. Okay? So, yes, we could make do with object and not worry about the interface, but what's the price we pay? Go ahead.
You'd have to change the class a lot if you want to add like a new shape.
Okay? So if we wanted to add a new shape like a triangle, we'd have to remember to come in here and add another else if s instance of triangle, cast it to triangle and paint it, which is kind of a pain. It's much cleaner with shape, with the shape, because you just say s.paint and the right thing happens. Sometimes you need to downcast. Sometimes you have, like imagine if you had a shape object and there was a special method that only existed for ovals that you wanted to run. Well, you couldn't take a shape object, you have a shape variable that contains an object. You can't run that special method that way. You'd have to first cast it to an oval and then run the method. So sometimes downcasting is necessary, but a lot of times you get rid of it just by having an interface. So if we go back, just to remind you, here's the same loop. By it. It's so small. That's all we have to do. No matter how many classes implement shape, that's all we have to do the painting. Okay? Any questions I could answer about that? Casting. Okay, now, so we are in, this is where we started. This is version 4, not 4a. And down here, we made everything work by having an interface that was implemented by the other 3 classes, by oval, rectangle, and line. And we did that because we wanted to have a subtype relationship. We wanted to have oval, rectangle, and line be subtypes of shape, so that we just have a list of shapes. But there's another way to get a subtype relationship. Implementing an interface is one way to arrange for oval, rectangle, and line to be subtypes of shape. What's another way? What's another alternative? Yeah?
An abstract?
Well, an abstract class, but we don't even have to use the word abstract. Just rare old inheritance. When one class extends another class, you get a subtype relationship. So we could go with using inheritance. So let's think about what that would involve. Why would you want to use inheritance? Make this a class instead of a interface. Yeah?
There were methods that were always the same for all the subtypes.
Right, so if there are methods in oval and rectangle and line that are the same, we could take the common code out and put it into the shape class and let the subtypes inherit that and only put the differences in the classes. So let's look at it. Here, oval keeps track of a center, a rectangle, a center, a radius, and a color. A rectangle keeps track of center, color, and width and height. And line has not a center, but start X and start Y, a point, and a color, and then ending. So what commonality do you see between these? What do all the shapes have in common? Yeah? Okay, so they all have a starting point, either a center or the initial point of a line, and they all have a color. So we can factor all that out into a shape class, simplify oval, rectangle, and line, and still have our subtype relationship. So let's go look into that with Paint 5. Make sure that I'm remembering this right. Okay, we're going to turn this into a class. So what I'm going to say is that it's a class. Shape is a class. Now, what's going to have to change down here with oval? Why does it have an error now? Right, it needs to, you don't implement another class, you extend it. So we'll have oval extend shape. We will have rectangle extend shape. We will have line extend shape. Okay? Now I want to think about what shapes have in common with these, with what all the shapes have in common. What we decide they have in common is, let me go down to here. In fact, I'm not even going to call it that. Essentially, these three pieces of information: start X, start Y, and color. So let's go up to shape and add to it those three private distance variables. Now we need a constructor, so let's put a shape constructor in here. And it'll have to take in as parameter an X, a Y, color, and we gotta say this dot start S gets start S. So we just got to save these into the variables. Okay, so I just wrote a constructor for shape. Now there's this paint method. Paint the shape on G. Why is it underlined? Yeah.
Have to provide some method body with language in.
Yeah. What he said was you have to provide a method body. It's not an interface anymore, so we've got to say, we got to give it a body. So we're going to have the default version of paint do nothing, and we'll rely on the classes that extend shape to provide a paint method that does something reasonable. Okay? Now that we've done all that, how can we simplify oval? What instance variables can we get rid of? Because we inherit instance variables. Yeah, we're keeping track of the point up in the shape class, and we're keeping track of the color. So I'll just get rid of those things. My comment's misleading, so I'll remove it for now. Okay, so we've got oval here, and it takes in an X and a Y and a color. And why is it complaining? Why are these things underlined right here in the constructor? Yeah? I took them out. They still need to be initialized. So remember, we need to call a constructor in the superclass. And so we'll pass it X, Y, and C. So we'll let the superclass, the shape class constructor, record X, Y, and C. It initializes those instance variables that we've inherited. We'll initialize radius X and radius Y. Yeah?
So I'm just kind of confused on the concept of like superclasses. So like, how does it know where to inherit X, Y, and C?
Okay, it knows it's inheriting stuff from the shape class. So it says right here is how it knows. Oval extends shape. So we're going to inherit these instance variables and this method.
And will it fail if it doesn't have all of like the three?
Well, just whatever variables and methods happen to be in the shape class are what we inherit. Okay? We'll come back to that in a second. What about rectangle? So we're sort of getting rid of this. And color. We don't need anymore. And we have to make the same change here. And same thing for shape. We don't need to keep track of this information anymore because it's being kept. It's the base class that deals with the point and the color. And this other information, this extra information is dealt with specially in the derived classes. Okay? It's looking good, except what's going on here now? We've got the paint. Yeah? Okay, so you can't access, we are inheriting these instance variables. When you create an oval object, it will contain a color variable and a center X variable and a center Y variable, although I think we called them something different up there. But we can't access them directly because they're private. So what are we to do? We got to know the color so we can draw it.
You need getters.
We need getters. Okay? So I'm going to do it in two ways. I'm going to take care of this. I'm going to say no, I'll leave it this way. We need a method to get the color. So we need a get color method. It doesn't exist yet. We need a get X method. And a get Y method. Where do we define those methods? Get color, get X, and get Y. Okay, right. I don't put them in oval because oval doesn't know anything about X, Y, and color. The shape class does. So we need to add try something here. I'm going to right click, go to source, and I'm going to say generate getters and setters. And I'm going to ask it to create, well, I'm going to deselect all, I'm going to select getters, and I'm going to say generate. And so it throws in, it just does all that typing for me. It creates a method called get start X, get start Y, get color. And actually I'm going to change the name of this to get X, and the change of this name to get Y. Okay, so we just added getters to the shape class so that we can find out X and Y coordinates and colors. And let's see, that makes this method happy. And we just got to go do the same thing here. Okay, and that fixes the last problem, and so if I run this, it ought to work just like before. Some sort of error came up, I don't know what that was. Okay, so we've got two things to compare. We have the class, we have the version I looked at before, which was just using interface, and the version now, which is using a class. So the other one had an interface called shape. This one has a class called shape. So there's a trade-off here. The shape class is a lot more complicated than the interface was. But what do we get for our trouble? How does a more complicated shape class help us? Yeah?
Expandability.
You said expandability, but the interface approach was expandable as well. If this didn't buy us anything, then why bother? It must be something that it makes simpler. Yeah?
Each of the individual shapes are simpler, so oval is simpler, rectangle is simpler.
Right.
Line is
So what he's saying is oval is now simpler. It only has 2 instance variables, whereas it had 5 before. And similarly, rectangle and line are simpler. Now, they're not dramatically simpler, but this is a simple example. In a more complicated example, the difference would be more stark. So when you, one reason I'm talking about this now is when you go to do the PS11, which is an asteroids game, I have created for you a starting point, and the starting point is an object-oriented framework. So there are lots of interfaces and classes and inheritance, and you'll work by, you'll be extending classes to create new things that are similar to the things that were there before. So you need to work with these ideas. And there's a more convincing illustration of why inheritance can be a good idea, just because the program's more complicated. But right now, I just want you to understand how these pieces fit together. So any questions I can answer about this one? Okay, so just to summarize, we've changed these classes so they extend a common base class called shape, and we put the things that all those classes had in common, which is basically an XY coordinate and a color. And that's what the shape object contains. Then we extend it in various ways to turn the shape into an oval, a rectangle, or a line. So what should we do next? I'm going to check to see what I did next. So okay. What functionality do we need to add? Yeah.
Allow the user to press down the button and click and drag to make the size of the shape.
Right. We don't have a way of, we want to be able to drag, after you click, to drag to size our new shape. So we need to add that. So let's think about that. But before we do, I realize there's one more, you can say it's a simplification or not. Is there anything that all the paint methods have in common? That the oval paint method, that the rectangle paint method, and the line paint method have in common? Well, let's look. Here's the paint method for oval. We set a color, and then we draw, well, this is rectangle. We set a color, we draw a rectangle. Up here in oval, we set a color, we draw an oval. Down here in line, we set the color, we draw a line. What did I say 3 times?
Set color.
Set color. So what we can do is, we can move, we can take this out. And again, you could argue maybe this isn't a big deal, but again, it just illustrates a concept. Let's let the shape class, its paint method, I didn't delete the right thing there. I never copied it, that's the problem. And we'll let the base class paint method take care of setting color. Now, what's going to happen when we run this program? Make sure I'm running the right one. Paint 5, I'll run Paint 5, and I'll ask to draw a red oval, and it's black. I ask to draw a green rectangle, and it's black. I ask to draw a blue line, and it's black. So I move the set color to that color line up into the method in the base class. So what's going wrong? There it is. Why is the color not being set? Yeah. Right. This method isn't being called because we're overriding it down below. Right? So when paint is called, this is what's called. This is, when you call paint on an oval, that's the method that's run. It doesn't run the overridden method. So we need to arrange for the original method to run as well. How do we do that? You say super dot paint. You can call it. So you can call the overridden method that way. And again, I've made the program longer this way, but imagine if there was a big chunk of stuff that was common to each paint method. Clearly in that case, you want to take the common stuff, put it up in the overridden method, and then just call the overridden method as the first step in paint. And that would simplify things. Yeah?
But why did the compiler know that the default color of that is black?
He's saying, why was it black? You know, instead of any, what's special about black? It was just because I had a method right here, get color. And no, I take that back. That method isn't, that's not the issue. It's being colored black just because that's the default color for a graphics context. Because we didn't set anything else. Okay, now let's consider the problem of dealing with the drag, the mouse drag. what are we going to have to do so that, just to remind you, I'll run the final version, so that when we place an oval, I'm dragging the mouse and I can shape it however I want it. And the same thing for a rectangle, and the same thing for a line. What's it going to take to make that work? Yeah?
Just a thought. So mouse clicked, it doesn't register until after you let go. Is that correct?
True. Mouse clicked registers when you release the mouse.
We do something with mouse clicked.
So he's saying do something with mouse clicked. That's close. Let's go up here and look at what there are. So right now we're looking at mouse pressed. And we need to keep catching that event because that determines the starting point for the shapes. Then we need to know, we need to be told as the mouse is being dragged. So mouse clicked, mouse entered, mouse exited, mouse pressed. None of that is what we need. We need to have something that's called as the mouse is being dragged. And for that, we need to implement an interface called mouse motion listener. And it has a mouse drag method in it. Okay? So let's take a quick break and we'll look at adding this dragging feature. All right, let's get started again. Okay, so we're going to make these ovals and rectangles and lines resizable. So let me show you the change I made to the oval class. So we already had the radii stored as instance variables, but before we were setting them to 200 or whatever, and here I'm just setting them to 0. So if this was the only change I made, what would happen when we ran the program? if we set the radius of the oval to 0? What would you see? What does a radius of an oval of radius 0 look like? Someone want to say it out loud? Yeah.
Would it be just like a single point?
Yeah, it'd be a single point if you could see it at all. So let's try this. So I'm trying to place ovals. I can't see that it's placing anything at all. Okay. And then I'm adding a method called set extent. So what set extent does is it gives you an XY coordinate where the mouse currently is. And it figures out what the difference between that and the center is, and the X center and the Y center. Figures out the two radii and sets them. So as X and Y move, this difference becomes bigger or smaller. And then when we paint, you know, it's looking up, it's using radius X and radius Y to do the painting, and so it will pay attention. So that just means that after you create the oval, before the mouse has been unclicked, but before the mouse button has been released, you want to arrange for set extent to be called as the mouse moves, and then you'll see change happen. Same deal for rectangle. So rectangle has a method called set extent that sets its width and height, and line has a method called set extent that sets the endpoints of the line. All we got to do is arrange for them to be called. So let's go up, and you'll see that if we go to the very top, you see I am now implementing something called the mouse motion listener that I mentioned. And mouse motion listener comes with a whole raft of methods we can override. And one of them is mouse dragged. So periodically, as you're dragging the mouse with the button down, this method will be called and tell you where we are right now. So, what should we do? What should we do when we get a mouse drag event? So I clicked and I started dragging the mouse. It doesn't call for every pixel. Just every now and then it'll say, okay, the mouse is here, now the mouse is here, now the mouse is here, and I want the thing I'm drawing to track it. How am I going to do that? Okay?
You have to paint it and give it the extent, which is going to give the radii. So this dot radii, and then you have to paint with that, right?
Okay, we've got to call that set extent method on the shape that we're drawing right now, and then cause it to be repainted.
We have to do it like every second.
So, what is the shape that we need? Okay, we got to call set extent clearly. So there's set extent we got to call, and we'll pass it e dot get x. So we pass it the current coordinates of the mouse, which come in that event. So the event tells us where it was. But we can't call set extent. It's not a method on paint panel, it's a method on a shape. So which shape do we call set extent on? There could be a lots. Where are we going to find the shape that we're currently sizing? Yeah? Well, the radio button tells us what kind of shape we're drawing, but I need the specific shape. Yeah?
Is it the last shape in the shapes array?
Exactly. It's the last shape in the shapes list. Because when we create this, we'll create the shape when the mouse is pressed. And we add it to the list. It'll be the last thing on the list. So we just need to get the last thing on the list and set its extent. So I say shapes dot get, and what should I use as the index? What's the index of the last thing in the shapes list? Yeah, shapes dot size -1. So we'll get the shape, which is either an oval, a rectangle, or a line, and call its set extent method. And then when we're done with that, we need to tell the panel to repaint itself. So that's a method we inherited. So we do the repaint to actually get it to draw. Okay? Why is there an error? Every one of those classes, rectangle, shape, and oval, this thing here has to be a rectangle, a shape, or an oval. I showed you all three have set extent methods. What's Java's problem here? Yeah? Well, shapes is, here's shape. So, got the shape class that we're extending. Set extent is implemented in every in oval, rectangle, and line. Yeah?
But it's not implemented in shapes itself, so it's not expecting this.
Right, it's not implemented, it doesn't appear anywhere in shapes. So all Java knows is this thing here is a shape object. And shape objects do not have set extent methods. So to fix it, we need to declare here. We need to give it a this. Now, what should we have this method do? Should it change origin X, origin Y, or color? There's nothing interesting we can have it do. So what's the point of adding a set extent method that does nothing? Notice that we have fixed our problem, though. Yeah? Yeah, so it's, what he's saying is, now, we have said now that any shape object is going to have a set extent method. But we don't intend this method here to ever be executed. What is the only purpose is so it can be overridden. If it's not overridden, then set extent will do nothing. So the only reason we put set extent method into the superclass is so all the other classes can extend it. And then if we have a shape object, we know we can call set extent. So now, let's see if this works. So red oval, red rectangle, red line. Now, what would happen if we, let's go back to paint panel. Let's make this method do something. Now, when I run the program, will it ever print out extent on the console down here? Okay? You're shaking your head. Why not?
Because that method will never be called.
That method never be called because it's overridden in every object that we have. So you'll see that I run it here. I've got to find out why it's flashing that. I got some little problem. Okay? You'll see that no matter what I draw, it's not printed. On the other hand, what if I went down here to, say, the rectangle class and got rid of that method right there? So I'm no longer overriding it. Now what will happen when I run the program? When I draw an oval, will it print extent? No, because it's overridden in the oval class. When I draw a rectangle, though, let's see what happens. I click and I start dragging. You'll see it's being called a lot, extent, but nothing. Why am I not seeing the rectangle? Because I didn't override it in the rectangle class. I took that code out.
Its radii are still 0.
Yeah, it has a height and a width of 0. So nothing changes. If I put it back, then it will stop printing out extent. So you'll only see extent printed out when the original method is called, and that will only happen if we neglect to override it in a base class. I mean, in a derived class. Okay? Now, the next change I'm going to make, the last change I'm going to make, is actually pretty simple. Let's go back to the original form of this. So there's a method, setExtent, and it does nothing. Not only does it do nothing, we want it never to be called. We don't intend this setExtent method here to ever be called. We want it to be overridden. And it'd be nice if there were a way to require it to be overridden. Now, with an interface, how do you require a method to be overridden? How can you make it? Yeah?
Aren't they just all required to be overridden?
Right. In an interface, you just give the declaration. You can't give an implementation. They all have to be overridden. But in a class, you can't do that. If I just do that declaration, it's going to say, this method requires a body instead of a semicolon. That's what I'd like to do. To do it in a class, you have to do this. You have to declare the method abstract. Actually, I don't want to make that change here. I want to make it in version 7.
That's 6.
Thank you. Let's go find where the setExtent method is declared. Okay? So what I do is I declare it abstract. And what abstract means is you're saying, I'm not going to give an implementation for this. This is required to be overridden. Now what's the error going to say?
It has a body when it refers to something.
Yeah. It says, abstract methods do not specify a body. So we need to remove the body. So in a sense, every method in interface is an abstract method. You just don't have to declare it abstract. Now there's one other thing you have to do. If you put an abstract method in a class, then this says shape, it has to be inside an abstract class. So once you declare a method abstract, you have to declare the class abstract. And you have to put it in the right order. So abstract class shape. So an abstract class is one that contains, generally, abstract methods. And, yeah?
So would the difference between an abstract class and an interface be that an abstract class can provide implementations?
Yes, so we ask what the difference between an abstract class and an interface. An interface has only abstract methods. An abstract class is typically partially implemented. So like this one here, it has instance variables, it has a constructor, it has getX, getY, paint, so on. It does not have, that's the only bit of it that's abstract. And this is very common, abstract classes are common. The thought process is, okay, I know a shape has a starting point and a color, so I can use a constructor. It has to provide a setExtent method, but I don't know how to implement that in general. So I'm going to make it abstract, so it's forced to be overridden. I intend paint to be overridden, but I don't want to make it abstract because I want it to be overridden, but I want to have the base version called from the overridden method. Now, what would happen if we created just a shape object? We just said shape S equals new shape. And we pass those parameters. So if we did, suppose we created a shape object and then we called the setExtent method on it. So instead of creating an oval and storing it in a shape variable and calling the setExtent method on it, we're directly constructing a shape. What's Java going to do if you create that object and then you call this unoverridden method setExtent? Yeah? Say again? Yeah, this is not going to let you do that. So you can, the reason is I can't. So let's try this somewhere. I need to have a method. I'll just do it here. I'm just creating a new shape and I've got to pass it an X, a Y, and a color. If you try to do that, it's going to tell you cannot instantiate the type shape. So if once you make a class abstract, you cannot directly create an object of that type. You can't say new shape. Because if you could, Then the next question will be, what happens when you call setExtent on that method? Which has no implementation. That would be a problem. And so to prevent that from happening, you can't create the object in the first place. Does that mean you cannot create shape objects? Yeah, you can't create shape objects. Does that mean that this constructor here will never be called? What's the use of that constructor? Yeah. Okay, it's called right here. So the reason you have constructors in abstract base classes is so you can call them from the classes that extend them. So yeah, right here, we create an oval. We call that constructor. Why is it safe to call the constructor here, but not to call it directly? Why is it okay to call it from inside the oval constructor, but not from anywhere else?
Because the oval is forced to implement abstract methods.
Right. The oval is required to override setExtent, which solves our problem of having a non-existent setExtent. Now you can pass the buck. What do you suppose would happen if we got rid of this? Right. Oval is extending an abstract class, so it's required to implement the thing it inherited. And it's going to say right here, that's bad, but one solution is to make oval abstract. And then someone's going to have to extend oval and implement the method. But that's not what I want to do here. Okay? So that's a fine point, but you'll see abstract classes. And it's good not to, don't be freaked out when it says abstract class. It just means it's been designed to be extended. In fact, has to be extended to be useful. Yeah?
If you're using like multiple abstract classes, you like make an object, the one that's like on the bottom, which constructor does it use? Like the original one?
Okay, so when you have a base class and a derived class, and then there's a derived class and a derived class, so imagine a chain of inheritance. So when you create an object at the bottom of the chain, its constructor needs to call, either explicitly or by default, a constructor in its parent class. But that constructor will call a constructor in its parent class. So it goes all the way up the chain to object. So every constructor is called all the way up.
So can it skip, like override and skip and call grandparent?
No, there's no way to name the grandparent class from a derived class.
Okay.
There's a super keyword which refers to the parent.
Right.
There's no super keyword, or grand super, or whatever we can imagine. Super, I guess is about how it has to be. No, you can't do that. Okay, so that's sort of our tour through inheritance. And we went a long way. We started with sort of a version that did nothing, and gradually we added features to make the paint more robust, but we also, along the way, we explored design decisions we could make, whether to use an interface or use inheritance or an abstract class or whatever. And when you're designing classes, the thing to realize now is there are two audiences you have to have in mind. So one audience are programmers who are going to use your class. They're going to say, let's say your class is X. So they're going to write code that says new X. And then they're going to call methods on your class. And that's how you've been thinking about things since the midterm. Who's the other audience you have to think of when you write a class? What's another way your class can be made use of besides just straightforward create objects and call methods on the object? Yeah?
Couldn't you have static methods?
Well, yeah, you can have static methods, but that's not what I have in mind, yeah?
People who modify or use code from your
Class. He said people that modify or use code from your class. The way I would put that is people who are going to extend your class. Because sometimes you put in methods, you design your class to be inherited from. And in fact, it's pretty rare that you write a class with no thought to how it might be inherited from in the future, and anyone inherits from it, because it's just not designed that way. When you design, when you design a class to be inherited from, you've got to have that in mind when you're doing it. You've got to make it easy to inherit from. You've got to decide, you know, these are the methods I figure need to be inherited, need to be overridden in a base class. Okay, now I'm going to show you, even though I said I wouldn't do this, the third form, so a polymorphism. We've looked at inheritance, we have looked at interfaces. The last piece is generics. And you'll see this in more depth if you take 2420, but I just wanted to introduce the idea. So this is a class that we've seen before. It's called MyMap. So the idea was we were implementing something that's sort of like a hash map or a tree map. Except, as you may recall, the key had to be a string and the value had to be a string. So we stored all the keys in an array in a list of strings called keys, and we stored all the values in a list of strings called values. Now, that was just to keep things simple. I would like it if the user, when they create, I'd like it to work this way. So when you create a MyMap, it works like an array list. You say something like, okay, I want the key to be an integer, and I want the value to be a double, let's say. So I wish I could do that. So what I want to show you is how to make it work that way. And you'll find out that making this change here is simpler than anything we've seen so far. It's simpler than interfaces. It's simpler than, when I say seen so far, I mean any form of polymorphism. I'm not going to show you all the fine points. The fine points make it kind of complicated. But, so let's think what we have to do. If you want to make a generic type, you just, up here, you do something like this. And what that says is, when the user creates a MyMap, they're going to give you two types in angle brackets, two classes. And internally, we're going to refer to one as key and the other as value. You can think of these as parameters to the class. And this is where the parameter is passed. So here, when we create a MyMap of integers and doubles, what we're saying is, use the MyMap code, but everywhere key appears, replace it with integer. Everywhere value appears, replace it with double. And then if someone creates a different kind of map, then the replacement happens in a different way. So up here, you give one or more type parameters, class parameters, and then we're going to have to modify the class. So we're no longer going to store an array of strings, a list of strings to be the keys. What should the type of the keys be? Key. Now there's no class called key, at least that I've imported. It's just right here. What we're saying is whatever the user says is that type, plug it in right there. Okay? What about that? How should that, what should I use instead of string right there? Let's go back to the top. You've got two choices, key or value. Yeah. So whatever the user says is the type of the value gets plugged in there. All right, let's see what else has to change. We're okay here. This will create a list of the right type, depending on what, how these are declared up here. Okay, put takes a string that's a key and a string that's a value and stores it in the array. Well, what type is the key going to be in our new generic class? Right, key is the symbol we're using. And what's this going to be? Value. And everything else works just fine. You're just changing declarations. Okay, when we go to remove a key, well, it's going to be a key, not a string. But it's working nicely because this list right here, key, or this one here, is an array list of key objects, whatever that turns out to be. Okay, we go to get something out. Well, we don't give it a string as the key, we give it a key as the key. And we don't return a string as a result, we return a value. Okay, and then, right, so that was pretty straightforward, yeah?
Why not make classes generic all the time then?
Why not make them generic all the time? Well, a class like this you would make generic all the time because it's really simple. But not, I mean, think of a class like big integer. It's not clear how you would make that generic. But container classes are typically the ones that are generic. All right, let's see what I've left out. Okay, so what have I messed up here? Yeah. It's just that this is supposed to be a map that maps integers to doubles, and I'm trying to use it with strings as keys and strings as values, like before. So I can either change all this code, or how could I make it work? What's the right way to make this work? I just instantiate it this way. We'll go from strings to strings again. And now that code is happy. So with the right kind of class, it's really simple to make it generic. Now, what makes it complicated is, suppose you have a class like a tree set or a tree map. Now, the thing about a tree set is the things that you store in a tree set have to be comparable to each other. They have to have a particular method, a method compare, or comparative, I can't remember which. And not every object has a compare method. And so when you make that generic, you have to say, there's a way to describe that I don't want, you can't plug any old class in right here, say. It has to be a class that implements this interface. So there are ways to specify that. So you can put constraints on, you put constraints right up here on key and value. So that's what we haven't gotten into. But if all you care is that it's an object, this works great. So that hopefully shows you, at least gives you a first look at generics. Now, the last thing I want to do is just show you these slides, and I don't have time to go through them in detail. I just want to show you what they contain so you can look at them later, maybe when you're forget something. So this is supposed to be a summary of the main points that we made on polymorphism. Okay, so we've looked at three forms of polymorphism. Generics, which makes code reusable because you can have, like the MyMap example, you can have different forms of MyMap, but only one piece of code. Interfaces and inheritance. So different ways of getting code reused. So things that people used to do. Suppose you had a programming language where you didn't have generics, interfaces, or inheritance, and you wanted a class just like that class, but slightly different. What would you do? How would you create the class? Yeah?
Just like copy and paste.
Say again?
Like copy and paste?
Yeah, you copy the class over, change a few things in it, and now you've got two pieces of code that are virtually the same but differ slightly. And that becomes a maintenance headache. So things that people used to do by copying code and editing, they now essentially do the editing in the language by saying, by overriding and having generics. And we just talked about what generic classes are. This is just an example straight from there. So you have the type parameters. We talked about interfaces. Yeah?
Sorry, quick question about generic classes.
Yep.
So when you're declaring the class, those objects that go in there, those little like
in the angle brackets.
In the angle brackets, is that like where is that made, or is that just arbitrary? Like, could I change key to be like keys or something?
Right. These are just key and value here are just names I made up.
Okay, so they're not necessarily objects that are declared.
No, in fact, they probably can't be.
Okay.
Like if I had made the parameter integer, probably wouldn't work. They're just the same way you make up parameter names. You usually make up parameter names to methods to be descriptive. Same thing here. You just make them. It describes what it's supposed to. The first type parameter is the key type. The second is the value type. If you look in Java, in the Java documentation, you see that the actual hash map class uses K and V. They tend to use single letter symbols for generics. I prefer to spell it out. Okay, we looked at interfaces, and this just reminds you that when a class implements an interface, it is a subtype of the interface. Similarly, we looked at inheritance. So the derived class is a subtype of the base class. So both of these, the subtype idea comes in. remember that when you have a derived class, its constructor must call a base class constructor. And if you don't put that in there, Java will try to put this in by default. And you get an error if there is no constructor like that in the base class. Okay? We know you can override methods. It's just a reminder here that you inherit, derived extends base and then overrides the method from the base class. So that's a common thing to do when you do inheritance. Here's something we didn't talk about. You can declare things in a base class protected. And protected is between public and private. So if it's protected, that means the only place you can access this method, other than in the base class itself, is in a derived class. So if we're standing outside of the hierarchy, we would not be able to see the method, that method right there. So protected methods are often used to, they're methods that we don't expect a user of the class to call, but they are methods we expect the extender of the class to override. So that's what protected is for. You'll sometimes hear people say that you should there are situations where you should declare instance variables in a base class protected. What do you suppose it would mean if a variable in a base class was protected? Suppose base here had a variable x that's protected. Could it be accessed from derived? Yes. But that conflicts with what I told you, that instance variables should always be private. Now, that's a matter of opinion, but in this class, my opinion's important. So if you want a protected variable, the right way to do it is to have it be private and then have a protected getter. Okay? We talked about abstract classes. This is just a reminder here when you flip through these slides what an abstract class is. And this is a reminder that you can't do this when you have an abstract class. You can't say new base. You can't directly construct an abstract object, or a class of an object of an abstract class. You can do it indirectly like I'm doing here. As soon as that goes away, we can say new derived, even though it calls a constructor in the base class. Okay? And I mentioned several times, when you do inheritance, you're setting up a subtype relationship. Same thing when you do interfaces. And this is just showing you that if you create a derived object, you can store it in a variable of type derived. You can pass it to a method that expects a derived parameter, and so on. You can also take a derived object and store it in a base variable. But you cannot take a base object and store it in a derived variable. So you can store an oval object in a shape variable. You cannot store a shape object into a oval variable, because that shape might be a rectangle or a line, and that doesn't belong in, that's not an oval. And this is something, I always ask a question similar to this on the final, and lots of people miss it. So let me just show you this. I've created a base class, and I have a method foo that prints out B when it's called. And I have a derived method that overrides foo to print out D. So if you create a derived object D and you say D.foo, we would all agree it prints out D. You've got to make that thing go away. Okay? But if I take that derived object and store it in a base variable and call B.foo, that doesn't change anything about the object. The object is still an object, a derived object. It just happens to be in a base variable. And when you call foo, it'll still print out D. A lot of people expect it to print out B. But no. The identity of an object and what it'll do when you call methods is set when you construct it. It's going to behave the same way whether you have it, no matter where you use it. Yes?
If there was a method in derived that was not in base, and you tried to call that method from base B equals new derived, if you tried to call that, would that throw an error?
Right, so if, what he's saying is, suppose we had a method bar in derived that doesn't appear in base. And we did this last thing. We said base B equals new derived, and then we tried to call b.bar. Compiler won't allow that because it's just looking at the variable type. It says this is, I don't know for sure what this is. It's something, it's either a base object or it's a derived object, don't know which. Can't in general tell. So it won't allow it. So you'd have to do a downcast to call bar. And speaking of that, that's the last slide right there that shows you instance of as a way of testing the type of an object. I think that's the last one. Oh, there's one more. So derived, D is an instance of derived and of base. Same thing if you store it in a different variable, but if you directly construct a base, B is not an instance of derived. And that's the last slide. That just reminds you how you can do typecasting, downcasting. And we got one question, 2 questions. Go.
Can we have a trio partnership for the asteroids project?
A lot of people want to form groups of 3. No, it needs to be groups of 2. If there's if there are groups of 3 out there, there are plenty of people that want partners. All right? The odd person out in these groups of 3. So thanks for reminding me about that. Anything else? Okay? So if you still need a partner, why don't you come down here and see who else shows up?